All right, so here we got applications of right triangles. We did some right triangle trig yesterday with SOHCAHTOA, and so today we're going to do some applications of that. So here we go. First thing I'm going to have you do is solve some right triangles. You're going to need your calculator today. It needs to be in the same mode we worked with yesterday. It needs to be in degree mode, so make sure you got that ready to go. They're going to leave some parts of the triangle empty and have you just finish it up. I'm going to start with a big B first. Big B, anytime it's a capital letter, it stands for an angle. And I know two angles already are 90 and 61.7. And I know all three angles of a triangle add up to be 180. So I'm going to do 180 minus 90 minus 61.7. And that gives me 28.3 degrees. So there's 28.3 degrees for B, for angle B. Now, I've already set these other ones up just to keep the video a little shorter. If I'm looking for side A, and I know this angle right here, I'm going to say that's sine. Sine is opposite over hypotenuse, so I'll set that up right here. And the calculator stepwise, all you have to do is punch in sine 61.7, make sure you close your parentheses, and multiply it times the 106.2 in your denominator. And we'll go to nearest 10, so I'm getting like 93.5. You want to check that as we go, 93.5. Maybe punch that in yourself. And then for side B, I'm going to use 61.7 again, but the B is actually adjacent to it. So I'm adjacent over hypotenuse. That's why I'm using cosine. Same steps, except cosine 61.7 times 106.2, and I get 50.3. All right, so if I'm going to stop the video and kind of check your calculations there, make sure you're good on how we're doing that on the calculator. Okay, one more. This time they gave me different information. They gave me both sides. So the quick thing to do to find a third side is just do Pythagorean theorem, which I did down here. A squared plus b squared equals c squared, except I knew c, so I'm doing c squared minus b squared. So I'm going to punch in 23 squared minus 13 squared. And that gives me 360, but you got to take the square root of that number, and you would get 18.9. Actually 8.97. So it's 18.97. So let's just go ahead and make that 19, or 19.0 actually. So we'll say D is 19. That's one part. Already got these other ones set up. Sine of angle F. So angle F is up here. That's where it'll be my theta, or F. Sine, remember, is opposite over hypotenuse, so it's 13 over 23. Now remember from yesterday, when you're looking for an angle, don't hit the sine button. You hit the inverse sign. Hit second sign, and you can just type in 13 divided by 23 and hit enter, and I'm getting this on my calculator, 34.4 degrees. That's an angle. And then cosine D, D is right here, so I'm looking for theta right there. I'm using cosine because I have adjacent and hypotenuse. So again, the button I'm hitting is this. I'm hitting this cosine, inverse cosine button. It's right above your cosine key. It opens a parentheses. I'm just typing in 13 divided by 23. So I'm hitting second cosine, 13 divided by 23. That's what you do when you're looking for an angle. If you're looking for an angle, you do inverse or second cosine or second sine. If you're looking for a side, it's regular sine or regular cosine. Just drop my calculator. All right, a couple of, I guess, application problems. This is while visiting Niagara Falls, a tourist walking toward Horseshoe Falls on a walkway next to Niagara Parkway notices the entrance to the Cave of the Winds attraction directly across the Niagara River. So he continues walking another 1,000 feet and finds the entrance is still visible, but approximately at a 50-degree angle to the walkway. She's pretty smart to know that. Okay, so here's the picture of where she is. She has walked, I'll draw on it. She's walked this way. All right, here's her entrance she's looking at. That's the entrance to the Cave of the Winds. And she's walked 1,000 feet, and the angle right there, I hope you can see, is 50. So part A says how many feet is she away from the entrance. So that's asking you for side C, like the straight line distance from where she is to the cave. So 50 is right here, so that's going to be adjacent hypotenuse, which is cosine. So I'm going to punch that in. I'm actually doing, because the C is on the bottom, I'm actually going to punch in this time 1,000 divided by cosine 50, and I'll show you why that's true tomorrow. And I get this right here. This should be, she is 1555.7 feet away. That's feet. Okay, and then part B, it says, what's the approximate width of the river at that point? So the river, I'm going to color on the picture again. The river's right here. It's side B. How wide is it? How wide is the river? So looking at that one, that's actually would be tangent, because tangent is opposite, which is what B is, over adjacent, which we know is 1,000. So I set that up. And because my 1,000 is on the bottom, my B is on my numerator of this fraction, I'm going to do like I did the first slide. Just punch in, just multiply 1,000 times tangent 50. Hit enter, and you should get 1191.8 feet. That's feet right there too. Hopefully it wasn't too bad. Let's try another one. Rafters of a house. It says house framers can use trig functions to determine the lengths of rafters for a house. Believe it or not, they actually do that. They first choose the pitch of a roof or the ratio of the rise over run. That's important. That's rise over run. That's the pitch they're using. Then using a triangle with that ratio, they calculate the length of the rafter needed for the house. Jose is constructing rafters for a roof with a 10/12 pitch. That's the rise over run. On a house that's 42 feet wide. I don't know if you can see it. There's a 42 down here on the bottom of the screen. Find the length x of the rafter of the house to the nearest foot. So you're trying to find, this. That's a rafter. These are all rafters. So how long do those rafters need to be? So that's our x. Now, you can see the triangle that's in there that they draw, right triangle. And it says 21, which is great, but that's the run. I need the rise. And so to get that angle, because they told me this already in the problem, it was 10/12. I'm not going to worry about the 21 yet. I'm going to find out what the angle needs to be. I need to find that angle so I can find x. I can't find x without finding the angle. So I'm going to do tangent. Theta's rise over run, 10/12. Punch that in your calculator. Because you're looking for the angle, remember, I'm punching this right here. I'm hitting an inverse tangent, sorry, and doing 10/12. Then I get 39.8 degrees, which is good. That's my angle. And because I have the angle, now I can figure out what x is. So what I'm going to do here is I'm going to go, didn't mean to do that. My angle's here. I'm going to do adjacent, which is 21 over hypotenuse. Adjacent over hypotenuse, that's cosine. So to get that answer, remember you divide when your x is in your denominator, so you're 21 divided by cosine 39.8, and you get 27.3 feet. And it needs to be pretty exact for those guys, so your roof actually makes contact there at the top. Okay, almost there. Last thing today is called angle of elevation and angle of depression. I got a couple pictures here. Didn't draw them. I took them, obviously. Angle of elevation is how far, like if you're looking up at that airplane, what kind of angle are you looking up at? Now, here's the deal. It must touch the horizontal. Like you see, this person's eyes create a horizontal line right here, but because they're looking up, it creates an angle from the horizontal to the plane. That's going to be our angle of elevation, or our theta. Now, the weird thing is the angle of depression, to be honest, it's the same thing, except it's horizontal from the plane looking down. That would be the depression angle. But hopefully in geometry you learned about alternate interior angles, like that angle and this angle are called alternate interior. So they're the same exact angle. So if you hear angle of depression or angle of elevation, they're both the same thing. Both have the same measure, called different things, but they both must touch a horizontal. Keep in mind they must touch a horizontal. All right, last slide. The Falls Incline Railway at Niagara Falls has an angle of elevation of 36 degrees. The railway extends a horizontal distance of 138 feet. Find the height and length of the railway. Okay, now you can tell I did draw this picture. Obviously, I didn't put the little mountain or the Niagara Falls or the railway. I just drew a triangle. Now, what's happening is the railway is going up Niagara Falls a certain length. When it gets up to the top, the height you always measure straight down. You measure perpendicular to measure height. That's why I put the right angle right here. And it says the angle of elevation is 36 feet. Remember, angle of elevation must touch the horizontal. That's why the 36 goes right there. And this problem is asking you for both. It wants the height, how high is it up, and also how long is the railway. So you have to do both. So I started doing tangent first. Tangent's opposite over adjacent. So I did that to get my height. I need to punch that in right now. Because h is in my numerator, I'm going to multiply 138 times tangent 36. Work that out, and I would get 100.3 feet. That's how tall, that's not very good. That's how tall it is. And to get the length, I'm using cosine because I need the hypotenuse. And cosine is adjacent, which is the 138 over the hypotenuse, which I don't know. So because my L is in my denominator, I'm going to divide 138 divided by cosine 36. And I would get the length is 170.6. Now, again, it's not degrees, it's feet, sorry. Now, again, I would stop this and make sure you can do those calculations, because the setting up the stuff isn't that hard if you know SOHCAHTOA. You just got to make sure you can do the calculations on your calculator correctly. So I'd stop and check that. I'll see you tomorrow. We'll work on this like we always do. Look forward to seeing you. See you. Bye.